Hello, everyone. My name is Neo. I'm here to guide you through the matrix of reviews and help you guys get to the promised land of success on your test. So let's begin. All right. So, for which of the values of x is the expression undefined? So, we know what undefined means. Undefined is when you divide by zero. So, the first thing, though, you always want to do is see if you can factor. I look at the numerator and I can see that um, they are both divisible by 9, so I can rewrite it as such. The denominator I cannot, so it's just as such. And so when is this expression undefined? This is when the denominator is equal to 0, and I solve and I get 7 over 9. So what value of x would make the expression undefined? 7 over 9. Hopefully that makes sense. For all vertical asymptotes, find all vertical asymptotes of the following function. So again, what's critical here is that you want to make sure that you factor. So with the numerator, we can definitely take out a 2x, and that's going to leave me with x minus 7. In the denominator, we can factor out a 2, which leaves me with x minus 7. Now, what I always do is I quickly distribute back to double check to make sure I didn't make a silly mistake. I did not. And here what happens is we see that the x minus 7's divide out, and I'm left with 2x over 2, which reduces to x. So this is actually just a line with a hole at 7. So when it says find all vertical asymptotes, there are none. Okay. Keep going. Find all horizontal asymptotes for the find all horizontal asymptotes of the following function. So horizontal asymptotes occur at extreme values. So what you want to find out here, what you want to ask yourself is, I put a very large value in for x, what happens? So first things first, the only thing I care about is this right here. And so for very large values of x, you have a big number squared over 2 times a big number squared, right? Well, the big number squares are going to do what? Well, we know the big number squares are going to divide out, and we're going to be left with 1 over 2. And that's your horizontal asymptote, okay? In other words, the top and the bottom are of the same size, and when that happens, we divide the leading coefficients. Okay, next one. Find all x-intercepts of the following function. Write your answers as coordinates. Be sure to select the appropriate number of x values. Okay, so when we see something like this, we know that the x-intercepts are when y equals 0. So this equation is 0 equals 5x plus 8 over 3x plus 27. And so I do realize that you can factor a 3 out of 3x plus 27, but what's always going to happen is we're going to multiply both sides of the equation by 3x plus 27. These will divide out, and we'll be left with 0 equals 5x plus 8. And when I solve this, I get negative 8 over 5 is x. So what we're doing here is, and what the instruction said from class is that you don't actually have to do this first step. You can jump straight to setting the numerator equals 0, insofar as nothing divides out. And you can see 5 and 8. There's no way that that's going to work with 3 and 27. So but you do want to see if things do cancel out, right? Because that changes the game up, as we saw in this example here. Okay, but that's not the case, and so the numerator equal to 0, solved, we got negative 8 over 5. Now it's asking for an ordered pair, so we just said it's x comma y. We just solved for x as being negative 8 over 5, and y is 0 whenever we're asked to find the x-intercept. Okay, cool beans. All right, skipped one. Let's do this. Find all y-intercepts of the following function. So the y-intercepts are when x is equal to 0. So the first thing I always want to do still is try to factor it out. So Let's see if we can do that. So little tidbit to try to help you do this. There's a lot of different ways of factoring, and everybody comes from a different background to learn how to do this. What I do on a test like this is I look at it and immediately ask myself, see if I see the numerator or denominator, doesn't matter. If you see like an ordered pair, sorry, not ordered pair, a binomial, then I'm going to think, maybe there's something that'll divide out. And so I always try that first. I put 5x minus 1, and then I quickly worked it out and saw I would get 10 and -1 in the middle, which would give me 9. So that tells me that's a quick way of figuring out what's the setup. So here, what's going to happen is we're going to have a hole when 5x minus 1 is equal to 0, right? So that would cancel out, and this is reduced to f of x is 1 over x plus 2, okay? And so if we solve this problem, what we end up getting was y-intercept is when x is 0. So if you make x 0, you get 0 plus 2, which is 1/2. Okay, so that means that you have 0, 1/2. Okay, and I just want to show you what it's going to look like. So this is always tricky. Let's do this. Okay, so let's go. And so let's see here. Let's go y equals x minus 1 divided by 5x squared 9x. And I gotta fix that. 5x minus 1 divided by 5x squared plus 9x minus 2. So if we look at this here, I'm saying that we know that when this is equal to 0, 5x minus 1, so when it's 1/5. So let's see here. Let's see if we can find 1/5. So 1/5 is somewhere. Well, you know what? Let's do this. We'll say x equals 1/5. See exactly where that's at. Sorry, it's where'd it go? Where'd it go? Where'd it go? Oh, there it is. Note, it's being Neo is a little hard to see sometimes. Okay. So see, it's undefined here at 1/5 is 0.2. We can see that's undefined there. And we are concerned with this point, which is 0.5. So that's a little overkill, but just wanted y'all to be exposed to like, why is this working out the way that it's working out? And that's the cool thing about math, right? Like, you can look at things from a number of perspectives and they should all give you the same result. Okay, let's look at the next one. Find all holes of the following function. Write your answer as a coordinate point in the simplest form. If no hole exists, express the whatever icon indicate that there's no solution. I don't know why I'm reading that. I'm not doing that. Let's see here. So find all the holes. So the holes, we just finished talking about that the holes exist if things divide out. And so here we're left with y equals, let's factor out the 3. We're going to get x squared minus 16. Here on the bottom we can factor out an x. We're left with x minus 4. Now this is real important because you might look at this and be like, okay, there's no holes. But the top is the difference of squares. And so we can keep going. We can factor this to be x plus 4 times x minus 4. And the bottom is still this. And so please look out for that. This is going to divide out. And we're left with 3 times x plus 4 over x. And so let's see here. So that's what cancels out is our hole. So our hole is going to be at when x minus 4 is 0. So x equals 4. Because you can't divide 0 by 0. And this is said find all the holes. So if this is where the x value is a hole, then what we can do is if the question is for you to find the I can't speak apparently. If the question is asking us to find the ordered pair, you plug into what's left. And you get 6. So the ordered pair would be 4, 6. Okay, so it's asking for that. But whatever cancels out is what's going to be your hole. And I hope that makes sense. Let's keep going. All right, determine each feature of the function. So let's do this. Change my color, make it stick out. Horizontal asymptote. Well, like I said, the first thing you probably want to do is factor. So what I see here when I factor is that the x values are going to divide out, and that's going to give me a hole. So we know that, I'm just going to do that real fast. So this will divide out. So that means that you have a hole at x equals 0. Right. And then the equation you're left with is x plus 4 over 2x minus 7. And so if I plug in 0 here, we get 0 plus 4 over 2 times 0 minus 7, which is negative 4 over 7. Okay, so that means I have a hole there. So yeah, so we got that part done. Let's go with horizontal asymptote. So the horizontal asymptote is these, we have x squared and x squared, so they are the same, so you divide the leading coefficients, that's going to be 1/2. Vertical, okay, so you're going to take this, set equal to 0, that's going to be 7 over 2. X-intercept, look, they're nice, they can tell you that the y value is 0. So if the y value is 0, then it's going to just be negative 4. We're just setting the numerator to 0, so it's just that. Note that it's not here because it's not at 0 because 0 doesn't exist. 0 is a hole. So that's the one thing you got to make sure you're clear on because you got to make sure you're consistent. And then the y-intercept, again, is when x is 0. So you're doing, let me write this out, 0 plus 4 over 2 times 0 minus 7. So that would be, well, that doesn't exist, right? What am I saying? That's not going to exist. Why does that not exist? Because this is no y-intercept. Because we said that you have a hole when x is 0, right? And so when x is 0, right? When x is 0, right? If that's it's here on the y-axis, and you're not going to have, since I said you had a hole there, it's not going to exist there. The point that the reason why I'm pausing here is I wanted to stress another point, which is there can only be one y-intercept, and this is an important question. Why must there only be one y-intercept? If there is a y-intercept, there can only be one. In other words, you can't add multiple y-intercepts because we are talking about functions. So if I do have two points, two y-intercepts, then this isn't a function, right? It fails the vertical line test. So that's another big point here, right? Again, this is the beauty of this, is that it has to all add up. Okay, so I hope that makes sense. Let's move on. Okay, plot all of the existing 5 features of the following rational function. Some may not be needed. If you get a fraction or decimal, then plot as close to the true location as possible. Okay. Keep in mind, I'm always going to look back through your work to make sure that it's graded correctly. So don't stress too much over that. So we need to find. Let's go ahead and figure out the roots. So again, the first thing you're always going to do is you're going to factor it. This becomes 2, x plus 5. The bottom, if we factor that out, that becomes x 5 and 4, which means we're going to have to have x plus 5, x minus 1. Notice x plus 5 is on the top, so probably x plus 5 is going to exist. So this divides out, and we're left actually with 2 over x minus 1. So what does this tell me? Well, I know I have a hole at -5, so we know we have a hole at -5 because that's what divided out. Set that equal to 0, you get -5. I'm going to plug -5 back into the function that remains, and I'm going to get -1/3. And so this means that I have a hole at -5 comma -1/3. So we're going to go in here, and I'm going to attempt to do this. -5, -1/3, that's going to be like right there. You get a hole. Oops. Right there. Okay. All right. So we got that. Now we want to go after well, I guess. So if we're using our friend here, we'd find the roots first, right? And so the roots are when x is going to be, when does it cross the x-axis? So that would be when y is 0. But because we're ending up with 2, there are none. This is NA. Okay. Now the reason why this is going to be NA, depending upon how you're thinking about this, you're left with this function, right? This is, and this is what I want to do. This is, this automatically, rational functions, the parent function of a rational function looks like this. So you know that this goes to 1. You have a vertical asymptote like that. Because of the x minus 1, we know it's a shift of 1. And then, what else do we know? We know that there's no like reflection over the x-axis because this doesn't have a negative sign. So if that's the case, then we know that this thing is going like this. We know we have, first off, the horizontal has to be here. We'll talk more about that in a sec. But we know that this has to go like this. Something like this. Okay. And why do I know that the horizontal asymptote has to be on the x-axis? Well, because this thing is bottom heavy. It only has an x at the bottom. So when you have an x at the bottom, we know the end behavior is that it's y equals 0. We know the vertical asymptote is 1 because if I set the denominator equal to 0, x minus 1, 1 minus 1 is 0. There is no togetherness. There's no these this is there's no quantity squared that's no quantity that is even. They're all odd. And yeah, did I do these? The y-intercept. Well, we can find the y-intercept, right? The y-intercept is when x is equal to 0. So let's change the color. There we go. All right, so when x is equal to 0, I'm just going to put this here. And this is going to become -2. So 0, -2. So this thing, maybe I should make that a little better because we know it's going to cross 0, -2. Okay. All right, so let's make sure. So vertical asymptote, we have the vertical asymptote here. Horizontal asymptote, we have the horizontal asymptote here. X-intercepts, there are no X-intercepts. And why are there no X-intercepts? Because there's a horizontal asymptote. Y-intercepts, we just did that, make Y is when X is equal to 0. And hole, we got our hole right there. Okay, and I'll write here, hole. Okay, all right, and there we have it. So was attempting gratitude, but kind of just jumped into what the answer was. I hope that makes sense. And one thing that's awesome to see here that I think is really important is that if you can think in multiple ways, you want to use repartee, you can solve it that way. If you want to think about in terms of what you've done in the past in terms of parent functions, you can do that. There's a ton of ways. This, by the way, also this too, just to be super clear here, and you're not going to be tested on this, but I just want to be super clear here. This is y equals 2 times 1 over x minus 1. So why am I showing you that? This is like almost like a slope, right? This is a vertical stretch by 2, right? So this means that the function has been stretched by 2. So and this means that this x minus 1 means you shift to the right 1. So you shifted it to the right 1, you stretched it by 2. That's what this is saying. Okay. All right. Let's keep going. So next one, we got for which values of x is the expression undefined? Okay, so again, the first thing you always want to do is you want to factor this out. So anytime that you can see you can take the square root of both of these and you have a minus sign, you take the square root of both plus minus. Okay. On the bottom, we can factor out a 3 and get x plus 4. Okay, so it says for which values of x is the expression undefined. So first off, notice nothing divides out. We broke it down as much as possible. Nothing divides out. We're going to take the denominator, set it equal to 0, and we're going to get x equals -4. Okay, and that is it. So when x is equal to -4, it's undefined. Okay, want to be clear about something. If it divides out, it's indeterminate. Okay, so what we're saying is, so like if you had something like x minus 2 over x minus 2, this is not part of the question, but if you had something like this, right? If you plug in 2, you get 0 over 0. 0 over 0 is not undefined. This is actually called indeterminate. So I'm going to go on a little tangent here, but bear with me. The reason why, let's say I'm going to use I used 2 earlier. Let me just change the number. Let's go with 5. The reason why we say a value is undefined. Neil's going to sneeze. Glitch in the matrix. Okay, the reason why we divide, we say it's undefined, is if you multiply both sides by 0, you get a statement that's a contradiction. You get 5 equals 0. Okay, this is why this is undefined. However, if you have something like 0 over 0, this is indeterminate because what happens, it's really hard to see black when you have sunglasses on. If you multiply by 0, you get 0 equals x times 0, which gives you 0 equals 0, okay? Which is true, which is valid. But this also says, I don't know what x is, because this is true independent of what x is. So we plug in 1 or 2 or 3 or 4. So what is 0 or 0? I don't know, right? It's indeterminate. You can't determine what the value is. Because if you multiply both sides by 0, you get a true statement, but you still don't know what x is. Okay, so that's why they're not the same thing. Little proof there. Okay, so this is, again, indeterminate. Right, so again, my point is that you do have to check to see if things divide out, because if they divide out, it's not undefined. Okay, all right. Moving on, find all vertical asymptotes of the following function. So, nice little function to factor out. So we're going to get f of x. I'm going to factor out a 2 on the top, so x squared plus 15x plus, now this is easy to divide by 2. This is just 10 divided by 2, which is 5, 8 divided by 2, which is 4. And here you have the difference of squares. Okay. And then we're going to take the top here. We're going to say, hey, can I break that down even more? Let's see. So the numerator, we have this. I just look at 54 and say that's 9 and 6. 9 plus 6 is 15. And I guess I should have been looking at the bottom, but I know the bottom's not really going to help me. The denominator's not really going to help me because these have 2's in them, and we know this one's just 1. So it's not relevant. So this is what we really want to look at, right? It's nice and pretty. And we're saying find all vertical asymptotes. So we know nothing's dividing out, so the vertical asymptotes are going to be restricted to these. So you're going to have to say it's just when 2x plus 3 equals 0 and 2x minus 3 equals 0. And so when you solve this, you get negative 3 over 2 is x, and when we solve this, we get 3 over 2 is x. And you may even turn and be like, Mr. Anderson, I want to solve using 4x squared minus 9 instead, and to which I would say that is fine as well. If you want to solve this, you're going to move the 9, divide by 4. You're going to get x squared equals 9 over 4. And so if you take the square root, remember when you take the square root, it breaks down to plus or minus 3 over 2. So because of the plus or minus, that's these two values. And that's it. So that works fine. If you want to do it that way, you're more than welcome to. Okay. All right. Let's see the next one. Find all x-intercepts of the following function. Okay. Write your answers as coordinate points. Okay. So again, step 1, moral of the story, you always want to do is factor. So x plus 9, x plus 8, factor the bottom. What is that? 8 and 2. We'll stress again, like, shouldn't be worried about this too much. Like when you're doing this, when you're factoring, you go to the back number, you say what times what? 72. That's 9 and 8. Can I add and subtract 9 and 8 to get 17? Yep. Yeah, these are usually cooked up to be the values that are closest. I mean, 9 times 8 is not the exclusive, right, factors of 72. You have 1 and 72. You have 2 and 36. Right? There's a lot more, but I always go with what's closest. You also know you got to go with closest because this middle number relative to what I can plug in is not going to be that big. But it's cooked up usually. Here with 16, again, I'm picking values that are close. I know 4 and 4 is the closest, but I saw 10, and so I was like, oh, 8 times 2, 8 plus 2. So you're just saying, hey, what times what is 72? And when you add or subtract, gives me 17. What times what is 16? When you add or subtract, gives me 10. Okay. Here, the x plus 8s divide out, and I'm left with x plus 9 over x plus 2. So again, remember, when x plus 8 cancels out, you have a hole there, so that doesn't exist there. So it says find all the x-intercepts now. The x-intercept is when y is 0, but we also said that's when the numerator is equal to 0. And you get x equals -9. And that's it. All right, find all y-intercepts. So the y, again, I'm going to sound like a broken record here. Factor! Yay! Okay, so this is going to become +2 minus 1. Again, the back is -2 because 2 times -1 is -2. The middle is 1 because 2 minus 1 is 1. X minus 1's divide out, so you're left with 1 over x plus 2. So the y-intercept is when x is equal to 0. So this is just like so. So it's 1/2. So the ordered pair would be 0, 1/2. Okay. So yes, very important if you're thinking about this. You have to factor first. You can't just go cold into it. It's better to factor. And also, like the advantage to factoring is if when these divide out, it's easier to plug in, right? So we should all be able to state that factoring is pretty straightforward. All right, so this one's saying find all holes. Right, your answer is a coordinate pair. All right, so again, what am I going to do? I just said it, factor, right? 2x, x plus 3. The bottom, we're going to factor out of 5, x plus 3. Huh, interesting. So x plus 3 divides out, and we're left with 2x over 5. So the whole is going to be at -3. If they're asking you for an ordered pair, then we're going to take this -3 and we're going to plug in there, and we're going to get 2 times -3 over 5, which is -6 over 5. Okay, so that gives me -3, -6 over 5. Okay. All right, and there's our whole. So again, let's stress the process. What did I do? You divided out, right? You factored anything that divides out. That's the whole. You set that equal to 0. Solve that. Take what's left over, substitute it back in, solve through. You'll get the y value. Okay. All right. So determine each feature. So we're going to factor out of 3. This one's interesting because what this breaks down to is 3. So what this is y equals 3, it's just what? It's just a line at 3, right? Only at 3, I'm sorry, at y equals 3, right? Only we know at when x is 3 right here, that's a whole. So we know we have a whole at 3, 3. Okay. Let's see here. So what's going on here? It's a line. It doesn't have a horizontal, doesn't have a vertical. It doesn't have an x-intercept either, right? Because the line's not on it's a horizontal line. It's not on the x-axis, so that doesn't exist. And the y is going to cross at 3. Okay. What's cool about what I did here, and I didn't do this intentionally to be honest, but what I like about this is when you look at this question, if you draw a picture, sometimes it helps you to see what's going on. So especially when it's something easier to draw, like this is just a horizontal line. You guys, everyone here should know that y equals 3 means it's a horizontal line, right? That helps you to think. So I want to stress that when you're doing these things, um, think in more than one way, right? That really helps you out. So even if you know what you're doing, still try to think in multiple avenues because that helps you to make sure that what you're doing is correct. So this is just asking us to graph. So again, I'm looking at I'm looking numerator denominator. There's nothing I can do here. So that's ready to rock and roll. So the root, I'm going to use root A. So the root is when we set the numerator equal to 0. So this is going to be x equals -5. So we know we have at -5, 0, we have crosses there. And I always like to do this, rewrite it as -5, 0, because, and in fact, I'm actually, I'm just drawing a line through this. Okay. I don't like to write x equals -5 because x equals -5 is a vertical line, right? So that might confuse me later. So I don't like to do that. Speaking of vertical lines, we're going to look for the asymptote. That's when the denominator is equal to 0. So this is x equals 1/2. I'm just setting 2x minus 1 equals 0 and solving. So at 1/2, we have a vertical asymptote. Togetherness is if you have any sort of quantity squared effects. We don't have that going on here, so we're going to write none. End behavior is a fancy way of saying what is the horizontal. So notice the exponents are the same here. The leading exponents are the same, so we divide the coefficients. I'm sorry, the degrees are the same, I should say, of the numerator and denominator. So we're going to divide the leading coefficients, which is 1/2. So this means at, they're not nice, 1/2. Let's say that's 1/2. Okay. Y-intercept is when x is 0, so that's going to leave you with -5. So I'm just be clear here. Neil can't see with his glasses on. Okay. Well, it's because I hit something up. That's why. Okay. Sorry. Whoa. Okay. So what I did was here and here, I plugged in 0, and so I'm left with 5 divided by -1, which is -5. Okay. So 0, -5. 0, -5. Okay. So this tells me this is going to be like so. If I need to, if I'm pretty certain that the next one's going to go like this. And I'm certain for two reasons. One, if I plug in, let's just say I plug in like a number like, well, let me put it this way. I'm pausing it because I'm having like 7 different ways. I'm like, oh, you could do this. Oh, you could do this. Okay. What I was originally going to say is if you look at this, if you're plugging in positive values, look, this is 2 times a positive value minus 1, right? So if you're plugging in positive, this is for the most part, the denominator is going to be positive, right? And if you plug in a positive value here for x, a positive times a positive is positive. So this thing is positive divided by positive, right? But and remember, there's one restriction where this is not the case, and this is at 1, like values less than 1/2. This wouldn't be true, but we've already determined that, right? We're saying to the right of that, right? Pun intended, sort of. So if you're looking at this and you're like, hey, values greater than 1/2, what's going to happen? This is going to be for values greater than 1/2. This is going 2x is greater than 1, so number greater than 1 minus 1 is going to be greater than 1. In the numerator, it doesn't matter what it is, because if you're positive plus positive is positive, so you're going to live in the positive realm. But if you needed to plug in more values, that was my other point. Again, pun intended. You can plug in whatever number you need to kind of get a more specific shape. Okay, I'll leave that to you though. Okay, so leave that hole. Again, there's no hole here, right? Because nothing divides out. So hopefully that makes sense. All right, next one. So plot all of the existing 5 features. Okay, so more of the same. So again, here you always want to factor out. This one's really interesting. So be careful because if I factor out a -3, I get x minus 1. I would encourage you. I know we're all pretty good at doing this, but you never know. Distribute back in to make sure that you do get the value there. I know that we all know how to factor, but it's still nevertheless pretty useful to distribute back in just to make sure you don't make a silly mistake. Bottom is the difference of squares, so x plus 1, times x minus 1. X minus 1 will divide out, which instantly means I have a whole here at 1, and I'm going to be left with negative 3x plus 1. So this is very similar to the example I did earlier. What's different about this one versus the one earlier when I had the rational function, when I say rational function, I just mean 1 over x. That's what the rational function is called, or that's what 1 over x is called. This is negative, so whereas the parent goes like this, because it's negative, these are flipping. So now we know it's going to have this sort of shape. Okay, but x equals 1. I'm going to go ahead and just find the whole because it's easy. I'm going to plug 1 back in. So this is going to be negative 3, 1 plus 1, which is negative 3 over 2. So I know I have a whole at 1, negative 3 over 2. Okay, so I'm just going to go here and go 1, negative 3 over 2. Negative 3 over 2 is negative 1.5. We got a whole right there. Okay. All right. What else? What else? So we know that the vertical asymptote is at negative 1. So we'll go to negative 1. We know we have a vertical asymptote here. We know we have a horizontal asymptote at 0 for 2 reasons. The parent function tells us that that's what's going to happen, but also the end behavior tells me that's what's going to happen, right? Because for really large values, x is going to get very big, okay? Or if you prefer, it's bottom heavy. The exponent on the bottom is bigger, so that's y equals 0, okay? However you want to think about it. I guess that's 3 different ways of thinking of it. What else? We did vertical, horizontal, x-intercept. There is no x-intercept because we have a horizontal. You could also be like, hey, y is 0, so y equals negative 3. It makes no sense. And then the y-intercept is when x is 0. So I'm going to take the simplified version, which is this right here. So negative 3 over 0 plus 1, which is negative 3 over 1, which is negative 3. So x 0, negative 3, 0, negative 3. And all of this should be making you very happy because this is all matching. Look. We know that right here it's going. It doesn't touch at 0, or at the whole, but it does. The function should be behaving like that. That aligns with what I'm saying over here. So the other one has to be like this. Again, I can use very simple logic here and say values to the left of negative 1. This is going to become negative, but if the numerator is negative divided by negative is positive. If you're like, you don't, that's too abstract, you're just waving your hands, Mr. Anderson. I would say, hey, look, all you have to do is just plug in numbers, and you can plug in a couple numbers, and you'll see that that's also the case. Okay. All right. So good enough. Let's move on. Determine each feature of the graph of the given function. Okay. So horizontal. This is again because we have x squared on the top, x squared on the bottom. They just divide the leading coefficients. This is just 5/3. We do want to factor, but I mean, I guess, yeah. I'm laughing because this is so simple, but factor like this, right? This divides out 5x and 3x plus 7. So that means that the whole is at 0, okay? Which also means that you don't have a y-intercept, right? Because the y-intercept is when x is 0. So if you have a whole there, that doesn't exist. And so if I plug in 0 into this one, let's see what happens. You get 5 over 0 over 3 to the 0 plus 7, which is 0 over 7, which is 0. So you have 0 zeros, or you get the whole. The vertical asymptote would be, I'm going to change the color here. Vertical asymptote is going to be when this value is equal to 0, so 3x plus 7 equals 0. So negative 7 over 3 is x. Okay, and the x-intercept is when y is 0. But let's see here. So when y is 0, it would be crossing at 0, 0 here. We look here because you just said this 5x equals 0. We know we have a hole here, so this is not here either. Okay, and so there it is. Okay. Find all the holes. So this is a great experiment of factoring. We're just going to factor the bottom first. It's going to become what? 8 and 1. Right, because I got to get in at 7. 8 minus 1 is 7. Negatives. So it worked out. The top, the reason why I did that is because I wanted to see maybe if I can beat the system, maybe, and say, okay, let's try that, right? Because if x plus 1 is going to cancel out, right, the other one's got to be 5, because 5x times x is going to be 5x squared, right? So if this is going to work, it's got to be like that. This is going to give me 5. We got to make that negative because you got to get -7, right? So -7 times 1 positive 1 is -7. And that does work because you're getting 5x minus 7x, which is -2x. So that's a way of kind of like knowing how the algorithm of delta math works and saying, hey, I'm going to exploit that. And that's fine. That's fine. I think those are good skills to have. Okay, so we knew that we suspected that we were going to have a hole. We ended up having a hole there because it's asking you to find the hole. So x plus 1 equals 0, so x equals -1. Take -1, plug it into the remaining equation. I hope at this point all of this is becoming a giant review for you. That's the intention. In other words, I'm hoping at some point this becomes, you're working through this like, okay, you're starting to see it's the same thing over and over and over again. Divide both these by 3, 4/3. So the answer is -1, comma 4/3. But getting your reps in is very, very important. Okay. All right. Next one. Find all the y-intercepts. Again, the first thing I'm going to do is I'm going to try to factor. So x plus 4, x plus 3. 4 times 3 is 12. 4 plus 3 is 7. X plus 4 cancels out, so we're left with 1 over x plus 3. Okay. And it says find all the y-intercepts. Y-intercept is when x is 0, so this is going to become 1/3. Okay. So 0, 1/3 is the y-intercept. This has a hole at -4, though. Find all the x-intercepts of the following function. So again, I'm going to factor the bottom. So one thing here, I'm not sure about 147. Well, okay. So I'm going to do this. So there's this cool trick. If you add the digits, if the sum of the digits, 1 plus 4 plus 7 is 12, if the sum of the digits is divisible by 3, so is the number. So all of these are divisible by 3. So I'm going to factor out a 3 first, make that a little smaller. So 84 divided by 3. And then 147 divided by 3. Okay, so that makes it a little easier on the eyes. Then I'm going to take the bottom one. I'm going to factor the bottom one out. I'm going to say, hey, I bet you 5x plus 7 is one of them. And it's got to be x minus 7 because, again, it's negative here. Let's see if that works. That's -35. That's 7. -35 plus 7 is 28. Yep, look at that. Beating the system. Okay, so it factors out like such. 5x plus 7 is going to cancel out. We're going to be left with 1 over 3 times x minus 7. We are looking for the x-intercept. X-intercept is when y is equal 0. So what does that tell me? That tells me that there's none, right? Because if y is equal to 0, if I solve this, 0 equals 1, so there's none. This is why, this illustrates why it's important to factor first, because these divide out, right? If you didn't factor, you wouldn't have seen that this divided out, and then you would have missed the question. Okay, and that's the last one. All right, so I hope this makes sense and this helps you get out of the matrix. I'll see you guys in the next video. Appreciate y'all working with me.